Okay, hi everyone, thanks for visiting Meetup. I'm Novica, lead data engineer at SmartKit, and my main focus are search engines, distributed data intensive systems, and big data systems. Our topic for today will be enhancing e-commerce product search and discovery using Vantage Discovery Platform. So, objectives for today are to understand some key concepts of search engines and semantic search. Then we will explore capabilities of Vantage Discovery Platform, and we will do a hands-on implementation of semantic search and personalization using the platform. So, you will have a chance to try it out and do implementation together with me. For those of you who will follow along and do the implementation, you can prepare your laptops. Actually, you will need only Google Colab, and that's it. Everything else we'll do together. First, I'll start with a brief history of search. Some first research and development in search area was pretty long time ago. In 1960s, we had some first engines that were using mostly regexes. It were matching mostly query tokens and query phrases with documents we have, and some of them were using Boolean retrieval, simple lookup of the tokens and phrases in the document corpus. Then from 1970s to 2000s, we have development of some more advanced NLP techniques, and the majority of search engines were using keyword search and statistical ranking. So on keyword search side, we have NLP techniques like stop words, where we are removing some most common words in language like as, the, and they. Those words don't bring any contextual and any meaning and contextual importance. Also, we have stemming, lemmatization, where we are reducing words and tokens to their base and roots, and that way we can easier match tokens with the document corpus. At statistical ranking side, we have algorithms like TF-IDF and BM25, but we'll go deeper into those algorithms later. And in early 2000s, most of improvements in search area was based on machine learning algorithms. So we have algorithms like learning to rank, where we are fetching candidates using statistical methodologies, and then we are re-ranking them using machine learning algorithm. Some of the engines were including ontologies and knowledge graphs also, with bringing external data to the search to get more relevant results. And from 2013, I would say we have a new era of search with development of some advanced NLP models like Word2Vec, BERT, transformers, and today we have LLMs. Using NLP models like that, we can encode and incorporate semantics and meaning to vector embeddings, and then we are able to do vector search and matching by similarity and matching by context instead of matching by keywords. But despite that, today majority of e-commerce search systems, and not only e-commerce actually, anywhere where we have a search, it's still based on keyword and statistical ranking. So let's see how systems like that look under the hood. This is an example of keyword search. So we have document corpus. In this case, we have e-commerce data set with hiking trail boots, waterproof hiking shoes, etc. And when we have a corpus like this, the first step is to create inverted index. We are creating inverted index where key is the token and values are documents that contain that token. And this way we can do simple lookup, and on the right side you can see the query path. So when we have a query, we need to execute the query, and in this case we have hiking shoes query, and the first step is query tokenization. So first we tokenize query, and we have two tokens, hiking and shoes, and in this step we can do query processing like stop words removal, stemming lemmatization, part of speech tagging or something like that, but for simplicity I left it as is. And next steps is to do inverted index lookup, and we are doing Boolean search using OR operator. So we are fetching all the documents that have at least one token from the query. And after that, we are doing relevance scoring using TF-IDF for BM25 or something like that. BM25 is, I would say, the first option today. And it's improved version of TF-IDF, where importance of word is taken into account. So TF means term frequency. We are checking the frequency of term in the query, and IDF is inverse document frequency, where we are checking the frequency of the term in document corpus. We use some algorithm like this, and we calculate relevance score, and those are the results. But obviously, system like this have some problems. So problems are exact match dependency. That's the major problem here, I'd say, because when we don't have a match between keyword and document corpus we just won't get results. So for example, if we have synonyms, some variations of the token, we just won't fetch relevant documents, and we will miss results that are wanted actually. And systems like these are not tolerant to typos, misspelling, so you can imagine that if you miss just one letter from the word, that word just won't be matched and we won't get results. And obviously it doesn't grasp any semantic meaning, so phrases like chocolate milk and milk chocolate are usually hard, distinguishing between them is usually a hard task for the systems like this. And we have a small corpus here with just few documents, but you can see some problematic queries for the keyword search systems, like footwear for rainy weather. When I enter this query, I would expect to get waterproof hiking shoes, for example, but I won't get it because there is no keyword match between them. Another one is shoes for a tropical location. I would expect to get in results casual summer sandals, beach flip-flops or something like that, but I will get actually waterproof hiking shoes and trail running shoes, which I think doesn't make sense. So now let's move to vector embeddings, and let's go a step forward to solving this issue. What are vector embeddings? So, vector embeddings are numerical representation of the data. If we have textual data, image data, videos, or something like that, and we want to feed them to machine learning algorithm, we need some numerical representation for it, and those are vector embeddings. What is important for vector embeddings is that similar items are placed close together in the vector space, and that's how we can fetch similar results. We have sparse vectors that are usually produced by statistical algorithms like TF-IDF, bag of words, BM25, and something like that, and they have high dimensionality because dimension of these vectors matches vocabulary size. So, for example, if we have vocabulary size of 30,000 words, then the dimension of the vector is 30,000. But most of the values are zeros. Non-zeros values are only for keywords that exist in the document. So we have a vector size of 30,000, but we are not bringing enough information and context into the search with that. Also, there are dense vectors, which are mostly produced by algorithms like Word2Vec, transformers, and today LLMs, and dimensionality is much lower, and almost all values are non-zero. So we are encoding, so models are encoding semantics and meaning into those vectors, and even if they have much lower dimensionality, they are bringing much more information to the search. Here you can see examples of sparse and dense vectors. And actually, dense vectors are the pillars of semantic search. This is an example, the same document corpus and the same example we had for keyword search. This is an example for in context of semantic search. So we have the same corpus, and first step is to enable semantic search. First step is to encode the documents and calculate embeddings for them. We can calculate embeddings using some NLP model, that small model that we are hosting. We can use OpenAI models, Hugging Face models, some self-hosted models, anything that produces vector embeddings for the given text. And then we are writing those embeddings to the vector store and actually placing them to the vector space. On the other side, we have input query, in this example, durable outdoor shoes, and we are creating embeddings for the query. We have to use the same embedding model that we used for creating documents embeddings, that we used for corpus, to be able to match and calculate similarity between them. And then we are doing vector search and getting the similar, but this time contextually similar items, and items with similar meaning, and we are scoring that and getting results. So usually, as Kevin mentioned, for the vector search, what are the most algorithms that are used to avoid calculating similarity of query embedding with all the vectors. We are usually using some algorithms like LSH, HNSW, some version of HNSW, Diskinen, or a lot of search engines have proprietary algorithms like Vantage. And Vantage Discovery Platform gives us semantic search, and as Kevin said, not only semantic search but also a lot of personalization features out of the box, and can help us a lot in solving the issues with keyword search that we saw. So now let's implement a similar example that Kevin showed you hands-on. So for those of you who want to follow along, you can find this notebook at GitHub, SmartCat Labs account, and SmartCat Vantage Workshop repository. You can just copy URL and open it using Google Colab, file, upload notebook using GitHub, and just paste URL here. Okay, first let's set up an environment, and we will use some standard libraries: Pandas, Pyro, Vantage SDK, and Hugging Faces dataset. Okay. So they're installing. Takes a few moments to warm up an environment.
In that specific case that you showed, that with that query of 3 words, would be then the embedding would be a lot of zeros, correct?
You mean here for semantic search or for keyword search? If we are using keyword search, all values will be zeros except these 3. So at some position we will have these 3.
The query embedding will be.
But for semantic search, all values will be non-zero values, because we are encoding meaning and semantics.
I understand what you're saying, but I'm not talking about the document. I'm talking about the query.
Yeah, query.
But the query, if there would be 3 words,
Mm-hmm.
then the 1536 would not be all a value.
They will be, a majority of the values will be non-zero, because LLM or any model will encode the meaning actually. It's not based on keywords at all. It will encode meaning, and that's why we will have all non-zero values. Okay? So, okay, libraries are installed now, and here is the set of utility functions. They are used just for display the results, so I'll just execute this cell. And let's go to the dataset. So the dataset we will use in this example is dataset of fashion e-commerce items. We have 37,000 items scraped from ASOS.com, and some of the items are overlapping with the demo that Kevin showed you. So we will we will see how to implement the things that Kevin showed you. The dataset is public on Hugging Face, so here is the ID of the dataset, and we can easily load it. We will load it into the Pandas data frame just to make it easier for processing. And you can load the dataset just by executing this cell. Okay, the data set is loaded, and here is what we have in it. We have ID, which is unique ID of the document, and we have columns availability, brand, gender, product type, style, color, price, and we have title and description, which are textual columns, and we can use these columns actually as for semantic search, and the other columns we can use for filtering. And also we have embeddings columns, but I'll cover that later. Okay, this is just this cell is just detailed displaying of the row, and we can see that title and description are pretty informative text about the product. And next step is to set up a Vantage account. You can visit vantagediscovery.com and click Start a free trial, and populate just a few fields. It's straightforward to create account, and you can start. After creating a Vantage Discovery account, we'll get an access to our Vantage console. Vantage console is our main touchpoint for developers with Vantage platform, and in this tab we will have list of collections. For now we don't have any, but we will create one soon. Then we have the tab API keys. Here we have a Vantage API key that we can use for authentication, and I'll need it soon, so I'll copy it. We have configurations for personalization features. We'll see it later. Usage tab, but we don't have any collections, so no users so far. And we have account details. And in here you can find ID of your account that we will need for creating a Vantage client. So here you have links to platform documentation and link how to find a Vantage API key. Now for initializing Vantage client, we need just account ID and Vantage API key that I've just copied. Okay, I'll paste it here. And execute next cell, so to initialize Vantage client. Okay, Vantage client is initialized, and now we are connected to the platform. So, as you saw in the example of semantic search, first step for semantic search is to create embeddings for query or for the documents. Vantage has a feature out of the box that creates embeddings for us. So we don't have to create embeddings ourselves. Vantage platform can encode the input text to embeddings that will be used under the hood. Of course, we can bring our embeddings, but this is pretty useful features. We'll use OpenAI in this workshop for creating embeddings, and we can use OpenAI key from this URL. And
question: what type of clients are supported? You're showing here Python. Which language?
Yeah, we have Node.js and Java, and we have REST API, of course. I'll copy OpenAI key, and now we'll create external key. Vantage external keys are keys for any third-party system we are using. That can be OpenAI, for example. If we would like to host model using Hugging Face, that would be Hugging Face API key, or for some self-hosted models, we can add any kind of external keys. Okay, and I'll create new model key. Okay, it's created, and in the Vantage console, when I visit API keys, we have model API key for OpenAI, and then this API key will be used below in the collections. So now we can create a collection. Collection is fundamental object of Vantage platform. I can compare it with, let's say, table in relational database, which we are using for organizing and managing our data, where we can add our items and query items using the collections, and generally it's used for the organization of the documents. There are two types of collections. Vantage Managed Embeddings collections. That's the preferred way to use Vantage, where Vantage platform creates embeddings for us using some of the most popular LLM models in the industry, or another one which is user-provided embeddings, where user can calculate embeddings and upload them. We will use the first option. We'll create OpenAI collection, and let's name it fashion items. Embedding dimension is 1536, and we will use LLM model text embedding tree large to get embeddings. And let's create first collection. Okay. In Vantage console now you can see first collection fashion items, which is empty for now. So let's add some data to these collections. Vantage documents we are uploading to Vantage platform need to follow some rules and need to conform to some format. And we have some required fields and optional fields. Required fields for every document we are uploading are ID, which is unique ID of the document. For the Vantage Managed Embeddings collections, text field is mandatory too, and for user-provided embeddings field is mandatory. There are some optional fields. So as you saw in Kevin's demo, we can filter by some fields, let's say color, brand, or something like that. Filterable fields needs to be prefixed by meta underscore. Also, we can do sorting by some fields like price, and we have meta ordered fields. That's the prefix for the fields that we want to be orderable. And we have operation. Default operation is update, but we can delete some documents and just send operation delete. And there are variants. Some product could have multiple variants, like the same product with multiple sizes, multiple colors, and we can define all the variants of that product and then later search by variants.
What would be text field? Is a combination of title and description, or
in this example, it will be combination of title of description, and we can use anything for text field, and it will be used for semantical matching. The data can be uploaded to Vantage platform using Parquet or JSON lines file, and we can upload it using console, SDK, API, or we can simply use document upload API where we can upload one or batch of the documents. In this example, we'll create a Parquet file and upload it using SDK. Let's first remind ourselves how the raw dataset looks like, and you can see again the columns we have, and we can use columns availability, brand, gender for filtering, so we need to prefix them with meta prefix. So I'll just rename these columns and I'll add meta prefix to the names. Okay, I'll execute this cell, and now we can see that filterable columns are just renamed to match Vantage format. Now let's create text field. I'll create text field using title and description. In this format we have title, and in new row we have description. And here I'll just drop some columns that we are not using. Okay, here's the final format of the data that we will upload to the Vantage platform. We have ID, which is unique, we have meta, so filterable fields, we have text fields, and we have embeddings. In this case, actually, we don't need embeddings because Vantage platform will create embeddings for us. But when we have embeddings column, which is in appropriate dimensions, it will take precedence on the text. So to save the time, I pre-generated embeddings, so we don't need to wait for generating embeddings for almost 40,000 items. And I'll save the file locally to the Parquet. Okay, and now I'll call upload documents method from the Vantage SDK on the Vantage client to upload this data to the platform and run indexing. Okay, it's uploaded. And you can see that the status of the collection now is indexing, where we are creating our indexes. So while we are waiting for indexing of the data, does anyone have any question, comment? Okay. And when we index data, then we will move to search, and now I'll just make a quick introduction to the search while we are waiting for indexing. So we have multiple endpoints and search types in Vantage platform. We have semantic search, where we are it is used for Vantage managed embeddings collections, and we can use these endpoints for semantic search, so search based on semantics and meaning with filters and sorting and other options. When we have user-provided embeddings collections, we are using embedding endpoints, and other endpoints more like these, Vantage Vibe and Shopping Assistant are personalization endpoints, which you saw already actually the demo for them. Now we will see how to implement them. Okay. Yeah, and for any collection, you can choose collection from the list and see the details about that collection, like ID, name, model that is used, and you can actually do a test query through the console UI. You don't have to to use SDK or endpoints or something. Okay, it's processed now. It will be online soon.
The difference between semantic endpoint and embedding endpoint is that on embedding endpoint, the user is handling embeddings.
Exactly.
Therefore, he has embedding of the query and he can pass it on to the
Exactly.
backend.
Yeah. So for embeddings endpoint, user creates embeddings with
Outside
any
the
model.
tool.
Yeah, outside of Vantage platform.
Yeah.
Okay, our collection is online, and now let's try to do simple semantic search. Let's try to query for Adidas sneakers. This is a very simple query, and let's try it out. And we can see in results that we've got a lot of Adidas sneakers, and this is actually very simple query, and we could expect that any keyword-based engine would return similar results, because we have a keyword match between query and results that we've got. You can see Adidas and sneakers in almost all results. And now let's try to add filters to it. So as you saw in the data set, we have meta fields that are filterable fields, and we can use them for filtering. This is the syntax for filtering, and now we will filter by gender and color, and we will sort by price. Let's have the same query with filtering and sorting. And you see that defining filters and sort is very simple, and we have everything in one line of code. And you can see only white Adidas sneakers that are sorted by price, as you can see. And now let's get a bit more abstract, and let's try outfit for gym cardio sessions. Again, let's check results, and we can see that we have a lot of items that are appropriate for gym, but we see that there is no keyword match between our textual query and the results we've got here, and that means that the results we've got are completely based on semantics and meaning. And now let's try elegant dinner party outfit. And we can see that we've got a lot of elegant dresses, and still we don't have any keyword match between query and resulting items that we've got. And let's get even more abstract with light and comfortable clothing for summer vacation. And we can see that we have some beach outfits, summer outfits for parties and something like that. And there is no keyword matching at all here in the titles and description with the query text. Now let's try more like this feature, and that's the feature that also Karen showed you. And let's take like this dress and just copy ID here, and we can hit this endpoint to get simply in one line of code to get similar dresses to this one, and we can see that we have in the results relevant outfits which are very similar to the dress that I chose. As you saw in the demo, that could be useful, for example, when user choose or select some item. We can show similar items to user very simply. As you can see, it's very simple to use it. Also, more like this feature, it blends multiple information sources like query text, embeddings that could be arbitrary embeddings. We could do embedding of some images, embeddings of some text sources, whatever we want. It just should match the dimensions, and we can use documents for our corpus. And results of this query will be based on context of all the information sources we've provided. So here we have query text outfit for long walks, and I took two items from here, this one and this one, and now we'll blend those information and actually more like this feature will blend it itself and get us results. And also we can wait we can actually add weights to some of these inputs. So I put weight 0.4 for text field, also 0.4 for one document, and 0.2 for another one. Okay, let's see results. And you can see the outfits that are similar to the items that I provided and to the text query, actually. Text query is outfit for long walks, and all these outfits are appropriate for long walks. And also we have Vantage Vibe, and this feature allows us to use both visual and semantic inputs, to combine them and to return results in some style, in some vibe. And now we will see how we can implement the example that Kevin showed us with floral vibe and images of some dresses. First we need to create vibe configuration and define LLM model that will be used for image processing and getting information from the images. We will use GPT-4o Mini for this, and we will create a vibe configuration named floral vibe. Okay, and in console, in configurations, you can see we've created a new vibe configuration. And let's see images for the vibe. So these are few images that we chose for style. We want to have search influenced by this style, these images, and as Kevin said, we don't need some constants like this. These are just random images from the internet. We could connect a system to Pinterest, Instagram, or something similar to get personalization and vibe from there. And now let's do a query romantic dinner that is influenced by these images. Okay, we can see results, a lot of dresses that are influenced by floral vibe and influenced by images that we defined. And next feature is Shopping Assistant, where we can create groups and where we can configure how we want to the search results to look like, and how we want to group search results. And for example, here I want to enter one query and to get full outfit. So I want groups shirt, pants and shoes, and with only one query I want to get items for full outfit. Again, we need to create a shopping assistant named full outfit assistant, and I'll enter a query outfit for business meeting, and I want to get a results in all groups that I've defined, which are results for this query. Let's do a query. Okay, and see the results. And you can see here that I have results in 3 groups: shirts, pants and shoes, and for only one query I've got full outfit and all results from all groups actually. And that's pretty much it. Does anyone have some question? Okay, thanks all for visiting the meetup. And now we can move to networking and to get some beers. Thank you.
Yeah, I wanted to say thank you as well. Great. Hey everyone. Phenomenal to meet you. My name is Kevin. I am Chief Revenue Officer at Vantage Discovery. How many of you are familiar with Vantage Discovery? Okay, we got 3 people. How many of you are familiar with SmartCat? Okay. How many of you are familiar with Hexaware Technology? I'm joking. All right. So I'll first start with a brief overview of who we are, and then from there I will talk through some of the challenges and the problems that we help our customers with. I'll go through a demo, and then I'll pass it on to Novica, who's going to actually walk you through what it's like to set someone up on the Vantage platform so that they can get amazing semantic search discovery right out of the box. How does that sound? Perfect. All right, so I would prefer if this wasn't a lecture. So if anyone has anything that they'd like to add on, any questions, comments, please just shout them out, raise your hand, whatever the etiquette here is, because it's a Friday. I'm sure that all of us would probably rather be in different places. And so let's try and have as much fun as we possibly can, and maybe learn a thing or two along the way. How does that sound? Okay, so Vantage Discovery was started by 2 folks, Lance and Nigel. Lance was actually one of the pioneers of search. So he was one of the foundational engineers who built Yahoo Search back in the early 90s. And since then, he's built about 3 or 4 search engines. He built one at Overture, built one at Verity, and then he's also the person who built most of the tech behind Pinterest. People here familiar with Pinterest? Amazing. Perfect. So he actually came into Pinterest via an acquisition. And once he got to Pinterest, at that point, Pinterest was fairly small. No one had really heard of it. And he built out the shopping platform and the ads platform, which is what really drives Pinterest today. If you would aggregate all of the revenue that Pinterest gets from their shopping and ads, it's about 75% of their revenue. And they're widely regarded as one of the best search and discovery engines. You go on Pinterest and you find exactly what you need, and you can go down and browse through, and it's just an amazing, amazing experience. And 2 years ago, he realized that with ChatGPT, that finally everyone could have that same experience in their retail store today. To get to where Pinterest is today, they spent hundreds of millions of dollars to develop their own LLMs, to develop all of their machine learning, to get that amazing search and discovery experience. But all of that is commoditized and available to us. We all use ChatGPT in our day-to-day lives. We all use Anthropic. We all use models from Hugging Face and all of these other companies. And so this technology layer is becoming more democratized. And our goal is to sit on top of that amazing innovation that's happening and give it to every single person who has a store online and wants to create an amazing personalized search, discovery, recommendation experience for their shoppers. We're not exclusive to e-commerce, but that's kind of where we started. But we also do have customers in publishing. We have customers in a few other areas as well. So anyone who has a search problem, you're trying to match a user with either a document or a product, I would like all of us to think of Vantage Discovery as really helping to solve that problem. Any questions so far on the company? Maybe a few other things I should mention. We're based out of San Francisco, out of Silicon Valley. We raised $20 million Series A, and we're seeing really phenomenal traction with super large retailers like Walmart, Salesforce, Shopify. And we also partner with much smaller organizations, organizations like Cooklist, like Whatnot. And so these are organizations that are, they serve about 10,000, maybe 20,000 products, and we're useful and we're helping companies along the spectrum. All right, so let's first start with the challenges that we help people solve. So is anyone familiar with the term Google tax? So Google tax is a term that came up a few years ago, and it's the fact that any e-commerce store has to pay a Google tax. And that Google tax is a tax for acquiring customers. So shoppers today, they're going on Google because they know that if I go to a Walmart.com or I go to an Amazon, I may not necessarily get the right product that I'm looking for, particularly if it's maybe a specific niche like fashion or something of the sort. And so you start your search on Google. Now what happens is Google, right, with the first three or four items that come up, all of them are paid. All of them, someone goes and bids for the keyword, and those are the recommendations, or those are the search results that you get. And so what happens in this case is that someone goes and they click on that specific line, they go to your store, and then they're like, hey, this is not exactly what I was looking for, so they go back to Google. And then you go to the next one, and you go to the next one, and you go to the next one. Each one of those clicks costs about $1, maybe $2, but that's the Google tax. If you actually look at how much some of these companies are spending on acquiring customers, it's in the tens of millions of dollars. And that's insane. Our goal is to help retailers to get the shoppers. We want shoppers that when they land on the site, they feel heard. They feel understood. They feel like you know exactly what they're looking for, and you can help them get there. That's our goal. Another thing that we hear from a lot of customers is that they know AI is coming for their business. They know generative AI is going to be disruptive to them, but they don't quite know exactly what to do. All right? And then the last piece is that once you start to cross maybe 1,000 products or so, then that experience actually becomes really challenging to make it engaging and to keep people on your site. And so these are some of the challenges that we solve for brands and retailers across the board. Any questions on the challenges that they face? Amazing.
So basically, you're talking about tax avoidance.
Tax avoidance, yes, exactly. Tax avoidance, right? That's a great way to put it. But yes, yeah. If we can help a retailer solve tens of millions of dollars, I'm all for it. Who wouldn't be all for that, right? Okay, and by the way, like the reason why they face these challenges is because it's hard. It's incredibly challenging, right? And the reason why it's challenging is that oftentimes when you go and you hit that search bar, the query that you put in is usually the lowest intent thing that's helpful in finding what you need. So for example, you're looking for, like, let's say I'm a shopper and I'm looking for red shoes, right? I go and I will type in red shoes. I don't know any better, right? Because I've been programmed for the past decade to think about what I need in terms of keywords, right? So I take, hey, I am going to a wedding event, let's pretend, and I'm like, I think I'll need shoes, and the type of shoes I'm looking for are red, right? And so I go and I type in red shoes. However, the problem is that those specific words, red shoes, don't actually capture the complexity for what I'm looking for. So what a retailer will do is that it will show me the highest selling product, maybe the highest margin products, and oftentimes those are red heels, red pumps, red sandals, right? By the time it actually gets to what I'm looking for, I've already left and I'm having someone else pay that Google tax, right? And so what we're doing here is that we are helping retailers, as I mentioned, understand exactly who their customers are, why they landed on your site, and what they care about. And so we coined this term called AI commerce. It's starting to gain a little bit of traction, but what we're really trying to do here is we're trying to bring back the joy to online shopping. And the idea here is that we want to create an experience that's uniquely tailored to you. You go in and walk into a store today in one of the shopping districts, like let's say it's a luxury store. Let's say it's, what's the equivalent of like a Saks Fifth Avenue here, right? You get a shopper who greets you at the front door and you tell them what you're looking for. And they will go and they will take you to a place and they will say, hey, you know what, you're looking for a sweater, you're looking for red shoes, why don't you try these on? What do you think about these? And you can go through that discovery process together. And that's what we're trying to recreate online. A lot of retailers struggle. They've spent decades optimizing that experience in the store, and we're trying to bring that same level of dedication, that same level of investment online, and you'll get to see a little bit of that in a second. So I will go through a demo, but before I do that, do we have any questions? Okay, so I'll walk through 3 features. This is just 3. There's a lot more features that we can walk through, but I really want to focus this session on the 3 main components. The first is semantic search, the second is Vantage Vibe, and the third is Shopping Assistant. So we'll first start with semantic search. Okay, so we're an API company, and so this front end is just a random template that we took, and so don't judge us on the front end. We're powering the products that show up. So this is a store. We went and we scraped about 150,000 products from a bunch of different stores, including ASOS and a few other brands and retailers. But the thing here is that one, we support all kinds of filters and facets that you would expect from a traditional keyword search, right? And this is a question that we get all the time, which is that, hey, people don't actually know how to search for stuff semantically. So can you support keyword search? And the answer is yes. We can support the same keyword search that Elastic, Algolia, and any of these competitors support today. Then, so here, the default search is blue kicks. The thing to note here is that none of these products actually have the word kicks in them. Did anyone else notice that? But we're able to infer that from the word kicks, the person actually means shoes, right? And with that, we're able to bring back blue shoes. Now, we can kind of scroll down and see all of the products that are brought up, but then let's click on this one. Another thing that we support is related products. Now, the way in which you do this is we're actually taking this main product and we're not just using the text in the title, in the description field, we're also using the image. I'll repeat, we're also using the image. Now, the reason why this is important is because when you're shopping, particularly in fashion, retail, the image is everything. An image is worth 1,000 words. Oftentimes, the description of the product doesn't actually do the thing justice, right? And so when you're trying to find related products, it's not enough to know that this is Puma Suede Classic 11 trainers. I had to go back to math for the Roman numerals. It's not enough to know that. What we want to do is we want to take a look at the semantically similar products based on the image. And that's what we want to bring back. And we can not only just do this for related products, we can also do it for complementary products as well, right? And this is something that is very, very rare. I haven't seen anyone else do this, at least as of today. Then, do you have a question? Okay, just stretching.
Sorry.
No worries, no worries, no worries.
Can I ask a question?
Yes.
I just noticed that they are not all blue.
Yep, so related products, right? It's about the semantic image in this case, right? And so what it's actually inferring, right, is that, okay, so here you have a sneaker with, it's not a swoosh, but a line that goes across, and it's able to infer, hey, maybe that's a determining characteristic. Maybe that's a feature because the user clicked on this product. Maybe that's a feature that they're interested in. And it's able to infer that, and as a result, you see all of them have swooshes, even though they're different colors, right? Even though the swoosh may be a different shape, like in this case, you have the New Balance, but it has a kind of, a pattern on it.
Might have been even nicer when it was sorted in sort of shades of blue first, and then to take your original query with it.
It would, yes, absolutely, absolutely. All right, so I will do another search. Let's see, I'll do a search for show off my muscles. And the reason I'm doing this search is because I want you to see that I want you to see the power of semantic search, right? So here, right, show off my muscles. That's the direction in which shopping is going, right? It's going to over time because people are starting to get trained by ChatGPT and they're starting to get trained on, hey, maybe I shouldn't think about what I'm looking for in terms of keywords. Maybe I should think of it the same way I just think or talk to a friend, right? And so this is a search query that people will be running in the future, show off my muscles. And as you can see, we're able to infer that the person is looking for something that's a little bit tight-fitting and a product that helps them show off their muscles, right? So you can see kind of what we return here. Now, what I'd like to do is to kind of showcase a little bit more about the semantic similarity feature, right? So let's say, for example, I don't like sleeves. So I'm going to dislike that one, and I will like this one, and like this one. So notice, by the way, more like this is a feature that's been there for ages. But the thing that we're doing here is we're combining more like this with less like this, and we're allowing a user to tell us a little bit more information. So not just a binary yes, no, but like you can actually say, these are the styles that I like, these are the styles that I don't like. And we're able to combine all of that and bring back products that don't have sleeves. And it's this combination that's incredibly powerful. All of a sudden, very much like a dating app, like Tinder, you can swipe right and swipe left on a product catalog so that you get closer and closer to the things that you're actually looking for. All right? A lot of companies can do more like this, but I haven't seen a company yet that can do more like these, where you take that discovery experience and make it fun, make it gamified, right? And you give people the opportunity to really showcase exactly what, to narrow down the search to exactly what they're looking for, assuming they came with an intent of exploration.
And your service is API, since it's API first, right?
Mm-hmm.
It's not, is it optimized for retail experience?
So right now, from a data ingestion side, the answer is yes, but it's not just useful in a retail context. So for example, we have a few prospects that we're talking to. One of them is Ringier Axel Springer, which is one of the largest publishers here in Europe. Another one is Hearst, which owns things like Men's Journal. And the two use cases here that we're talking to them about are on showcasing. So for example, you have an article showcasing recommended articles that the person should read based on the semantic similarity of the original article. Then the second is around the publishing and e-commerce intersection, where you have an article such as top 25 tips for running. And then within that article, you're showing products like, hey, here are trainers that you should be thinking about. Here's running gear, right? And so combining that blog with some products as well. So those are two publishing use cases that we support. And so from a data ingestion side, right now we're primarily retail, but the technology is useful regardless. Does that make sense?
Yeah.
Okay. All right, so I will reset this. Any other questions before? So that's what I wanted to show in semantic search. First feature down, 2 more to go. Does that make sense? You guys, okay, perfect.
How much of this relies on the metadata that you capture with the product?
Haha, I'm really glad you asked that question. So one of the things that we do extremely well is we take incredibly messy data and we make it awesome. And the way in which we do this is through the data ingestion pipeline. So what happens is, for example, we have one customer who literally sent us one image and the product title. That was it. And they're like, hey, can you make my semantic search isn't working, what's going on? All right? And so what we do is that, so we've, through the course of our history, we've ingested about 500 million products. And through those 500 million products, there's 2 things that we've learned. 1 is product taxonomies that make sense. And 2, how to do data embellishment in ways that make the product search experience awesome. So a very simplistic way of kind of thinking about this is we take what you give us, whatever it is. We'll look at the image, right? And we'll use an LLM through that ingestion pipeline to tell us, hey, what do you see in this image? What kind of person would use this product? In what occasions would they use this product? Why would they use this product? And as a result, we're able to augment that data that we get in our backend in order to, use it to facilitate like really amazing semantic search. So we do the data embellishment on our side such that semantic search just works for you regardless of how messy or how terrible or how sparse your data is.
Just out of curiosity, have you used this 500 million products to fine-tune this LLM to give better results, or are you using something off the shelf?
So we use something off the shelf. So we theoretically allow customers to fine-tune whatever model that they want, but we haven't found it necessary. In fact, with the Polish customer I was telling you about, we were incredibly nervous going into that conversation. We're like, hey, none of us know Polish. How is this going to work? We found out by using OpenAI model, in this case, it worked. And it worked well enough that we actually didn't have to go through the whole fine-tuning process. Now, on the recommendation side, what we could do is that in case your customers have ML models that they want to use, they could absolutely use that in order to filter out recommendations that aren't quite there yet. All right. So on the PDP, right, what we found is that some customers want to keep the ML models that they've developed in order to power their related products as like a last step filtering process.
One more question about this.
Mm-hmm.
So if the product doesn't have enough data, you actually create synthetic data to enrich that product information and then use that to make it.
Exactly. Exactly. And so all the models we use are off the shelf, but we also do support a customer bringing their own model if they like. And so you could actually search using embeddings as an example. All right, so next I'm going to show you explicit personalization. So first of all, I'll run a search, maxi dress. We'll do a male example and then a female example. So there's a little bit of gender balance here. Okay, so maxi dress. So look at all these products, right? These are all maxi dresses. Would you say we've done a good job on returning products? Have we done a good job on returning maxi dresses? Yeah. Okay, all right. So what we can do is, I apologize for putting you on the spot, by the way. So what we can do here is Vantage Vibe. It's our version of explicit personalization. Okay? So with that query, what I'll do is I will go and attach a style to it. And so in this case, I'll take the floral style. So what's happening in the back end is our back end is receiving these 4 images, right? And we're going to use these images in order to influence the maxi dress search that the customer put in. And so exact same search, maxi dress, but you get fundamentally different results. You get more floral, more bright, more summery types of maxi dresses. Y'all saw that? All right, I'll do it again. I'll do it again, but I'll do it with a different style. I'll do it with evening glamour. Again, the only thing that's happening here is we're taking these 4 images, and we're using it to influence the search. And the exact same query MAC address, but you get fundamentally different results. And so the thing that's really powerful here is that we're agnostic to where these images come from. We don't care. Some customers have implemented integrations with Instagram, where you can pull in a post from Instagram and say, hey, I saw a celebrity wear this dress. I want something like this. We have a customer who's done an integration with Pinterest, where you can bring in a board and then use that board to influence your searches. And this is extremely powerful because how would you describe your specific style? It's really hard. If you're not living and breathing fashion every day, it's really hard to be able to say, this is a style that I'm looking for. But if you see it, you know it. And that's the power here, right? And so all we're doing is grabbing the image and influencing the search result with that. So that's our version of explicit personalization. I'll show you implicit personalization. So this one's really, I'll do it very, very quickly because I know I'm in Europe, and so I know that PII is very, it's a very touchy subject, right? But here's an example of a query, shoes. And then what I'll do is I will turn on personalization, and then I'll say I'll do like a 0.2. And then I'll do, okay, so actually first of all, just notice, right, when someone types in shoes, there's a lot of different types and styles of shoes that are brought back by the search query. And then what I'll do is I'll do sports shirt, for example. And then I'll just interact with a few. I'll interact with a few and look at a few. And then now I'll go back and do my query again. No, not that. It was shoes, wasn't it? And now, with the exact same query, we bring back athletic shoes because we know you interacted with sports shirts. Now, I've tuned this up quite a bit, and so usually you wouldn't want to fundamentally change the direction that quickly. But this is kind of a way in which over time, as you get to learn new customers, you get to see what they're interacting with, as you get to see what they buy, you can help them through the discovery process to find the thing that they're looking for exactly. As I said, this is amped up quite a bit. It's amped up to the max. And so you wouldn't necessarily want to do that, but at least that showcases a little bit more of implicit personalization. Questions on either explicit or implicit personalization, Vantage Vibe, how it works? Happy to answer.
If you're doing this well, better than others, then Amazon will like to buy you. Because they have so much more data that so that context will be so much richer that with the little information which you said, I think if I understood well, you said we do what we have, we work with the data we have, and that's minimal because it's just a little session or just, but it will not be as much as a company like Amazon has. So for them, it will be that tool that you're creating, that intelligence, that will have such a big economics of scale for them. Am I right?
I mean, I think you're right. I think that makes sense. So, two things here. The first thing is that Amazon has some of the best AI ML engineers in the world. They have a trove of data too.
Yeah. So
But-
what is the advantage of your company then?
So the advantage of our company is that despite Amazon having all of this data, they haven't actually, like, when was the last time someone shopped on Amazon and had a really great experience?
No,
See,
that's my point.
that's-
So there's a lot of potential.
Mm-hmm.
And
Yeah.
yeah,
So-
if you combine that,
Yes, so I mean, obviously, if Amazon was able to do a lot of the same things that we do, they would be formidable. But our mission, like, we have grander ambitions than an acquisition by Amazon. Our ambition is to help retailers, small and large, to be able to compete against Amazon, right? We want them to have such an amazing customer experience on their website that customers don't want to go to Amazon to buy their fashion item or whatever it is. That's what we want, right? And Amazon, by the way, like, the reason why they haven't been able to move as quickly is because, one, legacy tech stack, and so it's really difficult for you to pivot, right? And then two, you also, like, if you're Amazon, I think what you're really trying to do is you're trying to protect your turf, right? And so every once in a while you hear they'll launch something really, really cool, like Amazon Rufus. Has anyone heard of Amazon Rufus? It's very similar to Shopping Assistant, but somehow, some way, maybe it's because they don't put in the amount of investment that's required, but somehow, some way, it just never quite hits the mark.
but I mean, if you have a customer like, I think that's Fab Fashion for you as a company, so they have a limited assortment, limited product portfolio. So if you have, like in Amazon, such a huge partners, then you have so much bigger portfolio on products. So then that similarity you are searching for is so much more precise, I think. So I'm just thinking loud out loud, like what are the challenges for this, and how do you deal with that?
The challenges for us?
Yeah, and yeah.
Yeah, so I would say so what we're trying to do, like, our vision is to make it incredibly easy for people to come and plug and play, right? You'll get to play around with our APIs in a bit here, right? And so what we're really trying to do is to make it as plug and play as possible. And right, Amazon is going to do what Amazon does, right? And there obviously is going to be a place for Amazon. I don't see Amazon necessarily losing market share anytime soon. However, right, like, we're kind of thinking about, or we're placing our bet on the smaller retailers. So retailers somewhere in the order of, like, north of 1,000 products. Below 1,000 products, like, semantic search isn't that powerful. But if you have somewhere north of 1,000 products, then semantic search can become really powerful. And if you create those, like, amazing customer experiences, we believe that you'll be able to win, or at the very least you'll be able to grow. And you won't have to necessarily pay that Google tax that we were talking about. The Amazon tax too. Yeah, exactly. So that's we're focused on this segment. Amazon will do what Amazon does, but we're focused on, like, okay, the players who are not Amazon, how do they compete in this new world of generative AI? That's the focal point. That's what we really care about.
Because if you are really making that possible, then they don't need to be on Amazon.
Exactly.
So when will you introduce the cross-site pixel cookie or whatever to track everyone along a lot of retailers?
Yeah. So glad you asked that. So we are right now we're actually building the cookie, but as we're building it, the one thing that we do know, the one thing that we don't want to do is we don't want to get any PII, right? And so all data is going to be anonymized, and so
At some point that's sort of dodgy, right? Because you know so much about the profile of a person, you can probably pinpoint them. If you not only have their style in clothes, but also what kind of labels in washing machines they like. At some point in time, you will be able to pretty much pinpoint people just by having so much metadata about the person, so much data about the person.
probably, but the power here is that implicit personalization is just one of many aspects, one of many like offerings that we do have. And so implicit, like in order for implicit personalization to work, you have to do the cookie, right? But that's one of probably 15 different capabilities that we've got. And so it's not something that we will necessarily live and die by, you know, particularly not here in Europe, for example. But that's the reason why explicit personalization is my favorite feature personally. It's my favorite feature because I don't have to know anything about who you are for me to give you amazing search results and amazing recommendations, right? I'm gonna ask you, tell me, like literally just give me a photo. It could be from anywhere. Give me a photo of something that you like, something that inspires you. And with that, I can get you such amazing product recommendations that you're like, wow, these guys get me.
That's really nice. I see a dystopia somewhere as well.
Do you do like a more lengthy searches that, you know, like combination of, as you said, style and, for example, what goes well with these shoes, but puts it a little bit in a 60s style. So I don't know anything about styles, about fashions. I got these shoes, and now I want to dress up.
Yep. Okay. So I have two answers to your question. So the first is complementary products, right? If you're actually looking at the shoe and you're wondering what goes with this, that's a complementary product. I don't have it in this particular demo, but that's something that we do, right? And a little bit under the hood about how that works is that we know that it's a shoe, and so you effectively ask the LLM, okay, what goes with shoes? Okay, if you're wearing shoes, you probably need pants. If you're wearing pants, you probably need a belt. If
I give you a picture of the shoe, then
exactly, you know the style, right? So that's one approach. Then the second approach is actually Shopping Assistant. So now Shopping Assistant is our version of a digital aisle, right? So the same way that you can have, like if you have a personal stylist, the stylist comes with like, hey, here are 10 products that you should think about. And so I will do a default query, why not? Fun day at the beach. Now, what's happening behind the scenes here is that with the specific query that the user ran, I want to have a fun day at the beach. We're going and we're running concurrent searches to find out what are all of the products that someone needs for a fun day at the beach. And then within these categories, we're going and finding the most appropriate items for that particular event. So you probably need a graphic t-shirt, you probably need swimming trunks, you probably need flip-flops, sunglasses, a beach hat, casual shorts, a beach tote, polo shirt. And so, I don't know if y'all see the power of this, but I was at a wedding a few weeks ago, and you know, my wife was, you know, for some reason she needs a new outfit every time we have to go to a wedding, and so this is a way in which you know your mission, you know your event, you know exactly what you want, like what you're doing, but you don't quite exactly know what you need to buy. And so here, what she did was that she came and she did this, and as a result, she got all of these amazing product ideas, right? Amazing for her, bad for my wallet, but she got all of these amazing product ideas, right? And she was able to be like, hey, you know what? I actually kind of want these shoes. Oh, hey, I want this dress too. And hey, I forgot. I should have gotten a hat as well. And so the power here is that all of a sudden you're able to create a digital aisle that someone will interact with and buy multiple different products. And so someone will come in looking for one product and they will leave with 10. And this is the thing that's incredibly powerful for retailers, right? It's that all of a sudden you can help them increase their conversion rates, you can help them sell more, you can help them increase the average order values. And so this is something that's incredibly powerful. And you could do a bunch of other queries, right? Like let's say, for example, after this, maybe we want to go to a pub. And so casual pub visit with coworkers on a weekday. What should I wear to that? You know what? Maybe you should think about a polo shirt, slim fit jeans, chino trousers, a crew neck t-shirt, denim jacket, lace up, leather belt. There's all of these things that you could potentially be thinking about that finally we're able to provide that experience so that shoppers come in looking for 1 or 2 items and leave with 5. And so kind of going back to your question, I'm sorry, I didn't catch your name.
Nashko.
Nashko? So going back to your question, Nashko. So if you had like we can support a query that's infinite words long, in quotes. But the power is that we can help you find, like if you had said like you have 60s shoes like in the 1960s style, we can help you find all of the like different complementary products to those particular shoes, right? Using the shopping assistant here.
How far can you go outside your primary product data using the LLM? Give you an example. Looking for a suit for a weekend fun with guys, and want to have Bedfellows look from the movie. So
Mhm.
it goes to LLM, looks at
Mhm.
Bedfellows, that gives me, which one I want to look like. I'm all set.
I mean, theoretically, it is possible. We could try it. You want to try it?
Yeah, let's go.
Okay, what was it? Wait, no, this is... I will go to the search. I'll just do a search if that's okay. Reset all. Okay. So let's try it. What do you want?
Night out, black suits with Bedfellows movie look.
I don't know whether we have products that would have that. All right. But let's see.
There are some top
I haven't actually seen. Let's see. Let's actually Google Bedfellows movie.
Bedfellows, I think it's Fellas.
Oh, is it Fellas?
Yeah. Fellas, yeah.
Bad Fellas. This is Goodfellas. Is it Goodfellas?
Goodfellas?
Goodfellas. Yeah. Okay. Okay. So.
I want to look like Joe Pesci. Capisci?
What do you think?
Yeah, this way.
So obviously here we're limited with the catalog that we have, but you do have, right? You do have some brands that the mobsters in Goodfellas probably would want to wear, right? But
Good Italian.
exactly. So it is 100% possible, and that's the value of leveraging like an LLM like OpenAI, right? It's able to infer exactly what you mean, and it's able to go and bring back products based off of that. And I mean, we're all in tech here, so we all understand, right? Like what it's doing is that it's taking that query, converting it to an embedding, doing a closest match on the back end with the products that you have, and then bringing back the most relevant products, right? At its core, that's what it's doing. And so there's no reason why you shouldn't be able to do that.
Can you lose black? Just remove black. Probably it will work because of Goodfellas style.
Yep. All right. Okay, so just very quickly, right? What is our differentiator? There's obviously a bunch of vector DBs, and y'all are familiar with, I'm sure, like Elastic and Algolia. And so what innovation have we really done here? And I think it comes down to three different things. The first is data, right? Recognizing that LLM embeddings are the new product DNA. That's kind of the first difference here. And so a lot of other providers, what they do is that they already had a database, and what they're doing is they're just bolting on AI on top of it. We're built with AI at the core, at the very lowest kernel. We're built for AI, and so this actually means two things. One is that we can support 100% recall in case that was something that was useful to your customers, which most other vector DBs can't because they use HNSW, FIES, or something of the sort, which approximates the actual like recall versus going down to the kernel. And so that's one thing that we do. Two is that we're written all in C++, which means that we are highly performant. One of our customers, for example, has 200 million products. 200 million variants, I apologize. 200 million SKUs. And we're able to run P95 at 50 milliseconds. Less than 50 milliseconds. P99 at somewhere in the order of 100 milliseconds. So highly, highly, highly performant. Then I talked a little bit about the data ingestion side, right? Like, because we've been able to ingest so much data, we're able to understand the different taxonomies, and we're able to understand exactly how to embellish data to make it awesome for semantic search, right? And that's really going down to the why. Why would someone buy this product? What kind of person would buy this product? And so when you search for Goodfellas look, right? And it knows that, hey, this is a person who, likes 60s style or something of the sort, it's able to bring back the highest relevant products. Then the second is personalization, right? We're able to personalize to an n=1 level. And so screw all that segment-based personalization, which is rampant in the industry. We're able to personalize direct to the individual. We're able to do it either from an implicit standpoint, if you're okay with cookies, or explicitly, if you're not okay with cookies, right? And then lastly, it's about search and discovery, right? At the end of the day, right, what we want to do is create amazing experiences. And so all of this is hosted. The way it works is that you send us a feed of your product catalog, and all you need to do is just hook us up to the search bar, and you get semantic search right there and then. Incredibly easy. Anyone can do it. And then if you think about the value here, it's about increasing conversion rates, right? How do you get people to interact with your product catalog, right? And to find things that they're looking for. It's about increasing average order values. How do you get people who come in looking for 1 item to leave with 5? It's about increasing the merchandiser impact. How do you empower merchandisers to be able to focus on higher value activities? And then finally, it's about lowering the cost of acquisition, so where you don't have to pay the Google tax anymore because the experience that you're providing is just so incredible that people come directly to your site and not Amazon or Google Shopping or any one of these super large aggregators and marketplaces. That's all I had. Any questions? Yes.
You mentioned you have on your side is anonymous. I have the company with my e-commerce. I have my accounts, so you create accounts on my side. I want to add this information. So on my side I can track because I know you are my customer, you have my account and use your services to improve the search. Of course, from your side you don't know because it's anonymous, but I can on my side to make this. Okay.
Absolutely. Yeah. So, and just to double click on the way it works is that you send us whatever information you want. Some customers send us clickstream data. Some customers send us shopping cart data. So this is what they already have on their shopping cart. Some customers send us, hey, this is what they've bought in the past.
Yeah, exactly.
Right?
For example,
And so we can accept any of that. It's just our cookie itself doesn't track personal
So for you, it's anonymous,
PII.
of course, not for me,
Exactly. Exactly.
I know this person.
Exactly. Exactly.
That means that I can basically, if I like this vase over there, I can take a picture, upload to some e-commerce that does, and just find the similarity.
Yes, you could do that.
That,
So just explicitly, right, as we mentioned, right, like we're an API company. And so I envisioned if, for example, y'all were to introduce us to one of your customers, right, or prospects, right, like someone has to do that piping, right? All we do is we have an API that says, we have a search API, we have a recommendations API, and so someone has to do the piping to do the front end that accepts images, right, and converts the images to base 64 because that's what we accept. Right? Someone has to do the work of doing the integration to Pinterest or Instagram if you want to include that as an offering. Someone has to do the work to bring in like ML applications for recommendations, right? And so ultimately, I think there's like the things that we do, but at the end of the day, we sell a product, right? And so with that product, there are a lot of services that can be attached to it around getting data, around cleaning the data, around organizing it, around the front end showcasing that data that y'all would still be in charge of. And so I think here, as I was talking to Nenad earlier, and I said that working with companies such as yours would be a win-win-win, where we win because we do the product sale, you win because you do the implementation and maybe even the ML work, and the customer wins because they get amazing customer experiences right out of the box, amazing shopper experience right out of the box. Okay, I'll be here, and if any one of you wants to talk, please come find me, and also I'm on LinkedIn as well. Kevin Omwega, O-M-W-E-G-A. I'd love to connect with as many of you as possible. But thank you so much. Really appreciate y'all for the time.